We're going to get into more types of angles that relate to circles, but first let's talk about some segments that are needed to create these angles, such as a chord. A chord is a segment connecting 2 points on a circle. What does that look like? If I draw point C and point D, and I connect those two with a segment, that creates a chord. So I would say segment CD is a chord of circle P. A secant is a line intersecting 2 points on a circle. So I could put a point on a circle, call it E, another point on a circle, call it F, and if I draw a line, remember the difference between a line and a segment? Line goes on forever. So line EF is a secant of circle P. So notice that a chord and a line look very much like each other, but a chord is a segment while a secant is a line. So a chord and a secant, almost the same thing, but they're segments and lines. Then we have a tangent. A tangent is also a line, or really any point of a line. So it could be a segment or a ray. This intersecting. This is a line intersecting a circle at 1 point. So how can you just intersect a circle at 1 point? Well, if I put this point here, I'm going to call it T. If I draw the line going into the circle, and don't draw what I'm drawing because this is not it. Remember that a line doesn't stop. So if I show that it stops here, it's going to keep going and eventually hit the circle again. But it's supposed to hit the circle at 1 point. If it hits the circle at 2 points, that creates a secant. So I need to fix how I draw this line to make sure it only hits at 1 point. So again, I'm going to put point T, and I'm going to draw the line such that it's only going to hit at point T. That's kind of tough to draw. Make it look like it just touches. Tangent, think touching. In fact, the word tangens in Latin is where we get that. It means touching. So this line right here, which I should put another point on it so that I can name the line, line TN is tangent to the circle because it's only touching at 1 point. So now that you know some more lines and segments related to circles, let's go ahead and apply them. Inscribed angle. An inscribed angle is an angle, obviously, but this time the vertex is on the circle. Notice in this picture the vertex of the angle on the circle, unlike a central angle where the vertex was the center. Now the sides of this angle I drew as secants, although they can really be any types of lines. So think about those sides of the angles, like the outline of the light of a flashlight. Here's where your flashlight is, and the light that goes out spreads as it's lit. And what part of the circle does it light up? That's called the intercepted arc. So this arc LN right here is the part that's lit up by the flashlight. The intercepted arc is the arc lit up by the flashlight, or the arc that's inside the sides of the angle. What's most important to remember here is that the angle measure equals half of the arc. What do I mean by that? Well, if that intercepted arc is about 80 degrees, then the angle is exactly half of that. See how it's really far away? Whereas the central angle, if I were to draw it, here's the center of the circle, and I draw the sides to L and to N, that's a wider angle, so that's also 80 degrees. But see how the inscribed angle is like twice as far away from that intercepted arc. So it's going to be half as big. See how as it gets farther away, it gets smaller. So this little angle inscribed is 40 degrees. This formula, really important to remember about inscribed angles. Let's do a few examples related to the inscribed angles. Find the value of each variable. So I see here's the angle, and I always extend the sides and draw it longer. Where's the vertex? On the circle. So first thing I do is think angle equals half of the arc. Not only do I think it, but I like to write it down. Then if we need to, we grab our highlighter and use it like a flashlight. Draw inside, and that sees where the light is shining. The light is shining on this intercepted arc that says 126 degrees. So the angle that I want is the x half of 126 degrees. That makes 63 degrees. Again, here in this next picture, I see an angle. I'm going to draw the sides and extend them. Where do the sides come together? At a point on the circle. So when the vertex is on the circle, I think and write angle equals half of the arc. So what's the angle and what's the arc? Well, let's do our highlighting, get our flashlight, see what part of the circle is being shined on, and it's this part. So this is the intercepted arc right here. The part closest to the vertex, that's the angle. So we write 5x, that's the angle, equals half of this arc, 9x plus 21 degrees. How do I solve an equation that has a half in it? Well, I see it's like dividing by 2. So what's the opposite of divide by 2? Multiply by 2. Let's rewrite this so it doesn't confuse us later. 5x equals half times 9x plus 21. I'm going to do the opposite of take a half, or divide by 2, which is multiply by 2. But I have to do it to both sides to balance it. So that leaves me with 2 times 5x is 10x. Those 2's are gone, 9x plus 21. Now that's a simple equation, no more fractions, so I'm going to get rid of the 9x, and x equals 21. Not bad, right? Do you want to try a couple more, pausing the video and come back? So in number 10, this angle is shown to be 20 degrees. So I'm going to trace the sides of the angle and extend it on past the circle. Here's the vertex of the angle on the circle. So think and write angle equals half of arc. Well, let's take our moment to get our flashlight and shine the flashlight and see what's intercepted. Here's the intercepted arc. Is that the one that we want? It's not, but we need it to help us figure out this angle. So let's do this. This arc right here we'll put in here. So the angle's 20 degrees equals half. The arc that we don't know, well, we can name it. Arc, measure of arc BC. Let's figure out what that arc is. How do we make the 1/2 go away? Like we did before, multiply by 2 or double the measure of the angle. So 40 degrees equals the measure of arc BC. Double it, get 40. How do I figure out the x? Well, think about what we did when we were talking about arcs. From A to C, that creates a diameter, so that's half the circle. That's 180 degrees. If I just want x, I have to take away that part because the x is just this arc. It's always going to be labeled in the middle. So 180 minus 40 to get 140. Let's look at number 11. This arc has a measure, 2x plus 10 degrees. This angle has a measure. It's made by a tangent and a chord, but I always extend the sides of the angle so that I can see the intercepted arc. Use my flashlight, see what's inside the angle, and I see the intercepted arc right here. The angle in that corner, that's a right angle, so that's a 90 degree angle. So again, the vertex is on the circle. Angle equals half of arc. Angle is 90 equals half of the arc measure, 2x plus 10. Notice I use parentheses when I have more than one number over there. Now I can multiply 2 to both sides to get the arc measure. That's a 180 degree arc right there. Now I can subtract 10 and then divide by 2. And there we have it. Let's take some time to look at an application of inscribed angles. One of them is basic, pretty simple. Here's an inscribed angle, and I'm going to extend the sides. The vertex is on the circle. So I'm going to highlight, and you see the intercepted arc is arc AB. This arc right here, intercepted. So if we were to give them measures, 80 degrees maybe for the arc, which means how much for the inscribed angle? Exactly half. Well, notice I have another angle in the picture, and I'm just going to color code it slightly different. So from D, drawing there and drawing there, notice how it's touching at those same points, A and B. So if we do the flashlight technique there, what do we see? It's intercepting the same arc. So how much will this angle be right here? Well, if the arc is 80 degrees, it's still true that angle equals half of arc. So this is still 40 degrees. The point is, if inscribed angles intercept the same arc, then they are congruent. So easy, they're the same. So let's just apply that to one little example and we'll move on. Find the value of the variable. Well, here's an angle. I'm going to trace the sides. Why do I know I'm using that angle? Because this little measure is closest to this vertex. If I do my little highlighter trick and shine my flashlight, I can see the arc intercepted, that part right there. That part of the circle. Well, here's another inscribed angle. Notice that it's hitting at exactly those two same endpoints. So I know this angle has to be congruent to this angle, and I go from there. 5x minus 2 has to equal 4x plus 9, and then we solve, subtracting the x's and adding that. And finally, inscribed quadrilaterals. Inscribed, every time we see inscribed, we want to think about the vertex, or because it's a quadrilateral, 4 vertices are on the circle. See, vertex, 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 vertex. Each vertex of the quadrilateral is on the circle. The main thing to remember about this is that the opposite angles add up to 180 degrees. They're supplementary. Opposite angles are supplementary. Why? Well, let's do a little exploration. So look for a moment. I trace the sides of this angle and just watch. The intercepted arc. Let's say that this intercepted arc is 160 degrees. How much would that inscribed angle be? Exactly half. So it would be 80 degrees. Well, if I trace the sides of the angle that's opposite from it, angle F, notice that that's touching at the same point, but that's the rest of the circle. The rest of the circle has to be 200 degrees because 200 plus 160 makes 360. So how much is that inscribed angle? Exactly half of 200, which is 100 degrees, and 180 make 180. Or we can think of it that the whole way around the circle is 360, So half of that, putting those two together, so divide it by 2 to get 180. So the opposite angles are supplementary. Make sure you're only doing that for when it's in a circle. So if I want to know what x is, I look what's opposite to that angle, because see the inscribed angles on the circle. So 3x plus 63 equals 180. And then opposite angles, 4y minus 1 plus 65 equals 180. And then just solve the equations. So solved properly, x is 39 and y is 29.